Okay, so we're going to talk briefly about the triangle midsegment, or a midsegment in a triangle. This is another type of special segment, and we've talked about medians and altitudes and things like that. This is a slightly different type of segment. What it does is it's a segment that connects two midpoints in your triangle. So if you've got a triangle, the midpoint of the side, remember, cuts the side into two congruent pieces. So by showing these markings, I show that this is a midpoint. And then if I want to do the same thing over here, I could put a midpoint right here and show that it's a midpoint by showing that it's congruent on each side of it. So if I connect those two midpoints directly to each other, that is now a triangle midsegment. Okay, so that's all a midsegment is it's a segment that connects two midpoints in the triangle. Now you can connect two midpoints from any two sides, and you got three sides. So that means there's actually three different ways we could draw a triangle midsegment in any one triangle. So I'm going to go over here and I'll find the midpoint of this side. Let's say it's right here. Okay, then I could also have a midsegment that goes from this point over to that one. Or I could have one, let me grab a different marker here, that goes from this midpoint to this one. So there are actually three different midsegments in any triangle, because there are three different pairs of two sides you could be connecting. So you're connecting one midpoint to another midpoint. And again, these congruence markings are what tells me there's a midpoint. Another way I could be told, sometimes maybe you wouldn't have congruence markings. Maybe you would have actual lengths. Maybe it would say this. By telling me that the actual length on both sides is the same, it's the same thing. It's telling me that these two segments, this one here and this one here, are congruent. That's what tells me this is a midpoint. So that's just a different way you could be told that you have a midsegment. So that's all a midsegment is. Now, what's most important about midsegments is their properties. They have two special properties, and those two special properties are given by the triangle midsegment theorem. The triangle midsegment theorem says that if you have a midsegment, now first of all I'm going to mark this so that I can clear that it is a midsegment. Remember, to show you have a midpoint, to show this is a midpoint, I need congruence markings on either side. Okay, the triangle midsegment says that the midsegment between any two sides is half the length of the third side and parallel to the third side. Now, what do we mean by third side? Well, we just said the midsegment between any two sides. So we're already involving two sides. We're involving this side and this side. Those two are the midsegment between those two sides. So the third side of the triangle would have to be the one side that hasn't been affected, which is this one down here. It also makes sense if you think about it, it's supposed to be parallel. So it would be the only side that this is parallel to. Okay, so that tells me, for instance, that if this has a length of, let's say, 11, then this whole side would have a length of 22. This is half the length of this side. The midsegment is half the length of this other segment that it's also parallel to. And remember, parallel means never touching. Okay, so there's a few different things we could do with that, or be asked to do with that. Let's look back at this picture actually. If I had 6 here and 6 here, then this whole side has a length of what? The answer is 12. So that whole side would be 12. And And which of the mid-segments is parallel to this side? Let me give it letters. Let's say Q, R, S. So I'm asking which mid-segment is parallel to side RS. That would be the red one. Okay, we can give it a letter too. Let's see, give it a label. Okay, so side A or mid-segment AB is parallel to side RS. So that means AB is supposed to be half the length of RS. So if AB is half the length of 12, then AB is 6. So you notice that this piece, and this piece are also actually all the same. Let's look at those elsewhere in the triangle. If I knew, for instance, that segment QB, from Q to B, had a length of 5. Well, remember that mid-segments are all about midpoints. So if that's a midpoint, this is also 5. And if AC, which is parallel to QS, AC is parallel to QS, if it's supposed to be half the length of QS, then it's also 5. So those three pieces, the mid-segment and the two different sides of the segment it's parallel to, the side of the triangle that it's parallel to, are all going to be the same length. All right, so numerically it's pretty easy to work with these. Let's look at an example that is algebraic instead, okay? And you have one just like this in your homework. So I'm given this picture. The picture tells me that this is a mid-segment. The way it tells me that is by showing me that this is a midpoint. These marks show me that this is a midpoint. And these marks over here tell me that this is a midpoint. So they have shown me with markings that I have a mid-segment. This then has to be half the length of the third side, the side it doesn't touch. So the third side, that's another way of thinking of it, is the side it does not touch. Okay? So we could set up an equation, but there are actually two different ways I could set up this equation. I could set up an equation that says this is half of this. Okay? So that would go something like, grab another piece of paper in case I go off the page. Something like this part again is half of this part. The mid-segment is half the length of the third side. So n plus 8 is half of 6n. And in this case, that's pretty easy to work on because 1/2 of 6 is 3. Ooh, excuse me. Going off the joint of the page. So I have n plus 8 equals 3n. Collect my n's on one side. 8 equals 2n. And n equals 4. Then I could find both lengths if I was asked for them. I could plug 4 back in and say that's 4 plus 8. The mid-segment length is 12. And 4 times 6, the third side has a length of 24. 6 times 4. Now let me point out, instead of saying, which is what I said here, I said mid-segment equals half of third side. That's basically what I just did here. The other way I could set it up, especially if this wasn't an even number, because I don't really want to take half of an odd number, the other way I could do it that works exactly the same is to say the third side is twice as big as the mid-segment. 2 times mid-segment. Remember, the example I've used on that is it's the same thing. If I say that I am twice as old as you, that's the same thing as saying you are half as old as me. If you are half as old as me, then I am twice as old as you. Two different ways of setting up the exact same relationship. So the third side, that would be 6n, is twice as big as the mid-segment. So 2 times n plus 8. You do have to remember parentheses here because it's 2 times the entire length of the mid-segment. So 6n equals, and I'm going to distribute 2 times n, 2 times 8, and then I'll collect my n's on one side. I get 4n equals 16, which means that n also equals 4. I get the exact same thing no matter which way I do it. So I can either set it up mid-segment equals half the side length, or side length equals 2 times the mid-segment. Either way works. And that would be mainly for problems, I think it's like 21, 22, 23. This is how you want to set them up. So your assignment again is pages 200 and 201, 10 through 23, and you now have all the skills you need to work all those problems perfectly. See you tomorrow.